Series Mathematics for Senior Secondary School. In this class, we are moving to a new topic. If you have not watched my video on indices and exponential equation, please check the YouTube channel to watch it. Then the second topic we took in logarithm, where we taught the laws of logarithm with tables, that is, then how to check your logarithms of numbers, reading them from the table, checking the antilog, how to solve some arithmetic operations on logarithm of numbers greater than 1. In this class, we'll be talking about geometry, and we'll be taking some of the theorems that will help you to solve some problems when you see them. In geometry, if you have some theorem that you are very familiar with, when you see problem, you know how to address the problem by linking one or two properties of the theorem you have known, by linking them up with the given problem. So if you are not familiar with this theorem, there is no how you are going to solve the problem with ease. So I'm going to start with what is called angle at a point. Angle at a point, if you know the point, when we draw a circle at this point, the angle of that circle that is drawn from that point is 360. So we say angle at a point is 360 degrees. He said angle at a point is 360 degrees. So that is the first theorem we are going to take. Then the second one we'll be taking is angle on a straight line. So when you have a straight line, you know angle on a straight line. This is a straight line. So if this is the point, by the time you are drawing angle at this is 180 degrees, and this place is also 180 degrees. So when you add them together, it proves that this is equals to 360 degree. Angle at a point is 360 degree. So angle on a straight line is, so you can now say the second theorem, sum of angles. So in case you are given some angles drawn from it, you say sum of angles, which sometimes I'll be using this to show angles on a straight line, is 180 degree. So some people can say supplementary, you still mean the same by saying sum of angle on a straight line is 180 degree, or angles on a straight line are supplementary. That means when you add them together, you get 180 degree. Number 3, when you have two lines crossing each other, I have a line like this, I have a line like this. This angle, let me label it A, let me label this B, let me label this to be C, and let me label this to be D. Then I can say that my A is equals to C and my B is equals to D. And the theorem that supports this states that what? Vertical opposite angles are equal. That is the third theorem. Number 3, we have vertical opposite angles are equal. So when you are familiar with this, The next thing we are going to consider is when we have two parallel lines. Number 4. When we have two parallel lines and a transverse drawn from those two parallel lines. So let's have the two parallel lines. So having two parallel lines like this, two parallel lines drawn like this, and a transverse like this. So this line segment here is parallel to this line segment, and if we have this angle to be A and we have this angle to be B, if this is C and this is angle D, this is E, we have this to be F, if you have this to be G, and you have this to be H. So what are the relationship between all these angles? From this place we have seen that A is equals to C and B equals to D. Here we have seen that E equals to G and H is equals to F. Vertical opposite angles are equal. So then we now look at some of the other theorems that we can get from this. So the A part we'll be talking about is what is called corresponding angles. Corresponding angles are equal. What are corresponding angles? Looking at this line segment on the transverse and this line segment on the transverse, since this and this are parallel to each other, angle B is equals to angle E. Why? Because the position of this one is corresponding to the position of this. How do I mean corresponding? B is at the top and right of the angle. Here is at the top and right of the angle formed by the transverse and this parallel and this line. Top and right of the transverse and this upper line segment. So therefore B is equal to E. They are corresponding, they are at the same position. So A is equal to H. Why? Because this is at the top left, this is at the top left. So they are corresponding to each other. Then D is equals to G. D is equals to G. Why? They are corresponding because this is at the bottom left and this is at the bottom left. So then we have C is equal to H. Why? They are corresponding. This is at the bottom right, this is also at the bottom right, though they are corresponding to each other. So the theorem supporting this is corresponding angles are equal. So let's take the next one, B. We have what is called alternate angle. When you have two parallel lines and they are forming something like a Z or a laterally inverted Z, two parallel lines, a transverse with a transverse forming something like Z. You see it is coming like Z, like this, like this. Then we'll say this angle here is alternating to this. This angle here is alternating to this. So we'll say that D is equal to E, and we have this one looking like a mirrored Z. C is equals to H. C is equals to H. This you call alternate angles are equal. We are going to talk about adjacent angles. Two angles are said to be adjacent if they have a line they are sharing in common. So this C and E are adjacent line. of a parallelogram. The same thing, this D and this H, they are adjacent angles of a parallelogram. C and E are adjacent angle of a parallelogram. So we now say that the C plus E is equals to 180. Then D plus H is also equals to 180. We say that they are what? Sum of adjacent sides angles of a parallelogram are supplementary or 180 degrees. Then the next one we are going to consider has to do with triangle. If we have a triangle drawn like this, I have a triangle drawn like this. If we call this A, angle B, angle C, and angle D, we can bring out two theorems from here. The first one is angle A plus B plus C is equals to 180 degrees. This is sum of angles in a triangle. Sum of angles in a triangle. That is the fifth. This is the A part of it. And the next one is the exterior angle here is equals to the sum of the opposite adjacent angles. So to get the exterior angle of this angle C, it will be equals to the interior angles summed together, removing C from them. So we now have angle D to be equals to A plus B. So why? Because C is the interior on this, and this make sum of angle on a straight line to make up 180 degree, and sum of angle in a triangle is also 180 degree. So you see that A plus B plus C is 180. The same thing, C plus D is 180. So that shows that A plus B will be equals to D. So you now say when you add these two interior angles together, it gives you the exterior angle at point C. So this theorem will say exterior angle in a triangle is the sum of two adjacent angles, adjacent interior angles in the triangle. So thank you for watching. In the next video, we'll be taking some concrete example on this and the techniques you need in solving problem that has to do with geometry. Thank you.